Shanghai GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
Shanghai GDG.
We're live? Awesome. Hey everyone, this is Ain Valdez with the Google App Engine Developer Relations team, and we're here today to talk about Cloud SQL and App Engine. And we're pretty excited about Cloud SQL for a variety of reasons. In particular, we had the data store, which was great, non-relational data stores, super scalable, really great way to persist your data. But we had a lot of developers that wanted to use traditional relational databases, and so late last year we announced Cloud SQL. And so we're here to talk about Cloud SQL. I've got a couple of my colleagues from Google. I have Joe Faith, who's the product manager for Cloud SQL, and I have Wally, who's also on the engineering team. So we're going to talk about it, and why don't we get started? We have some slides that Wally's going to put up, and then Joe's going to give us a quick introduction to what Cloud SQL is, some of the highlights, and then we're going to talk a little bit about, we have a presentation to show you some of the strengths, some of the interesting tidbits, and then we're actually going to go into some code samples, and then we'll come back to Q&A. So go to the moderator link as we go through. If you have questions about anything, just go ahead and put the questions in the moderator, and then I'll come back and make sure that we answer them all. All right, why don't we kick it off?
Start.
Joe?
Okay, so we know that Google's got this phenomenal infrastructure, the infrastructure we've built up for Gmail and for search. And the question that we've always been asking ourselves on the cloud team is, how do we take that awesome infrastructure and package it in such a way so that you guys, external developers, can make the best use of it? We want you guys to share share the infrastructure that we take advantage of every day. App Engine has been a great success in how to do that. It packages up the power of the infrastructure we've got so that it's scalable, but built on standard languages like Java and Python, which makes it a lot easier for you guys to get started. NoSQL, as I mentioned, the data store has been a key part of the success of App Engine. You just find it so easy to get started with the scalability. You just don't have to worry about so many of the scalability issues you do with so many other data sources. But we heard you guys saying, we want SQL. It's familiar, we've built so many applications on it, and it's got some key features that you just can't get with a NoSQL data store. It's got your robust schemas, it's got your generalized queries, you've got your transactions, and of course, data store does a certain amount of that, but there's always stuff that you want out of SQL. We listened, and we thought very carefully about how to package up a true relational database to take advantage of Google's infrastructure and would fit in with the App Engine ecosystem. And Cloud SQL is what we came up with. We had a few key design choices. The first was which database. There's an awful lot of them out there. We went initially with MySQL. It's the most popular open source one out there. So many of you are familiar with it, and it's matured a great deal over the years. It's now a robust enterprise class database. In some ways, it was the obvious choice. But then, how do we make it? The other choices we wanted to make were we wanted to get very nice integration with the existing App Engine ecosystem. That meant using standard drivers from Java and from Python, JDBC, Python DB API, but at the same time make it managed. We know what a headache managing any kind of database can be. You've got your security updates, your versions, managing access. We've all been there. We've all carried the pager. Basically, we're now carrying the pager for you guys. No more calls at 2 o'clock in the morning. We also thought very carefully about the replication model. We care a great deal about your data. Over the years at Google, we've learned an awful lot about replication, about data durability, and the importance of it. When you're carrying people's data at the scale that we are in Google, it becomes second nature. You don't take any risks with the data. That's why we went with the decision to, as standard, make your data multiply replicated across multiple data centers. There's two underlying reasons for that, and they often get conflated and confused. The first one is data durability. When you insert data into a Cloud SQL database and you return the call with an ACK saying, yes, we've got your data, we have got your data in multiple places, in multiple systems, in multiple locations. This is synchronous replication. We're then in a position where we're robust against very, very large outages. If a farmer plows up a main network cable, or hunters shoot down the cable, and they have done this. Hunters seem to take great delight in shooting down network cable. Even if that happens, your data will be safe. Not only will it be safe, and we're all familiar with the idea of taking backups, as our grandfathers and grandmothers tell us, keep taking backups. Not only do we take backups, this also means that your data is available. If a hunter gets trigger happy somewhere in the United States, there'll be another data center that can take up the load with no loss of availability. So it's durability and availability built in as standard. That was a very important design principle for us. We've noticed that organizations, enterprise businesses, put the data they really care about in a relational database because of the aspects like transaction processing. That's obviously why, say, financial institutions opt for relational data stores. So the last issue was over pricing. And we wanted to work out how can we make best advantage of our durable, available, distributed, replicated architecture, but then make that available to you in the way that you'd be happy with. And a key aspect is what we call per-use pricing. Now, often when you're buying up a relational database service, you're paying from the moment you create that database to the moment that you delete it and lose all your data. In the case of Cloud SQL, we've got what we call per-use pricing. That means you're only paying for the time when your database is actually being accessed. If your database is cold and you're not using it, then you're not paying for that access. And that was a key decision for us. It means that if you're just trying out the system, if you want to see it's going to be suitable for a particular project, create your database, play around with it, don't have to delete your data, don't have to get rid of it, but if you're not using it, you won't be paying. That's per-use pricing. We've also got packages if you've decided, yes, that Cloud SQL is going to fit for your application, then we've got packages which make it cheaper to use on a persistent basis. But those are some of the key design decisions we took when making Cloud SQL. And I think it's worked out quite well.
So that's, which I think really great about the way Cloud SQL is implemented was that it's very similar to the App Engine model, which is sort of easy to use, easy to manage, easy to scale.
Yeah.
And that ease of use from a SQL, because I remember managing SQL database was always painful. And so that I think the managed service part of Cloud SQL is actually super important. And as we kind of go through and show you some of we made it really easy to manage. But I think it is important to also think about you can actually mix and match these models. So you may need data store for certain things, but you also may need a relational database, and we can use the two together.
Yeah. In some ways, it's a very good point that we've had quite a few questions. Well, which should I use? And there are advantages and disadvantages of both. Alfred Fuller, do you see that?
Yeah. There's a good Google I/O talk on this. I think it's Battle of the Backends. Battle of the Backends, and it compares Cloud SQL and SQL. It's got two engineering teams competing with each other.
It's actually funny.
It is a comedy.
You might not believe me that a debate about NoSQL versus SQL relational data models can be funny.
It is. It's definitely worthwhile to look at. But it is easy to mix and match the two and use them. I've done it before. I think the last thing you might want to point out is. The other nice thing is it's super easy to make them talk to each other. So, maybe Wally will talk about this and we'll see in the code, but I think the authentication part is actually, it's really easy to connect your App Engine app right into Cloud SQL. You don't have to manage a bunch of nonsense. It's just sort of, you connect them.
No more nonsense.
Yes, nonsense is no good. So maybe let's switch over. Wally, do you want to kind of walk us through some, you have a couple different slides you can talk a little bit about?
Okay, so let me go through this slide here. So the first slide that I'm going over is getting started. How do you start using the Cloud SQL. So to sign up actually is really straightforward. So what you do is you go to the Google API console, and once you log onto the console, you go to the services, then you will see there's an option for turning on Cloud SQL. So maybe I can step through you real quick here. So here I have an account that I logged on already. So if I go to code.google.com APIs console here. So this is my console here. So if you click on the services tab here, then you would be able to see the Cloud SQL.
And it's likely, Wally, that if you've written against any Google APIs, you probably already have access to the console today.
Right.
Yeah,
right.
So it should be familiar.
So here, if you have pricing defined already, then you can just click on turn it on here. Okay, so once you turn on your Cloud SQL, then all you have to do is to install the Google App Engine SDK and install the Google plugin for Eclipse, and you're all set to go. And that's all you have to do.
And there's a good tutorial on that online for that as well.
Right.
Yeah.
So once you went from the API console, you can actually create a Cloud SQL instance. So from here, in the screenshot here, you can see that I have 3 instances created here. And there's a way to say new instance right here. And then when you select the new instance, it allows you to select 4 different sizes, ranging from D1 all the way to D4. So on the screen, you can see the differences between D1 and D4. So for D1, it's the smaller one. It gives you half a gig of RAM and 1 gig of storage, all the way up to D4, and which gives you 4 GB of RAM and 10 GB of storage here. Okay. So once you set up all the database instance, then you can configure access. In one of the access control, it allows you to specify which Google App Engine application you can allow. You're allowed to access that particular MySQL instance. So let me see if I can go to. So this is one of the Cloud SQL database that I have here. And if I go back to this instance here, if you scroll down here, then you can see this authorized application here. If you select edit, it will allow you to specify the Google App Engine application that you're allowed to access that instance of the database.
And you can have multiple App Engine apps shared,
yeah,
right?
Okay. So from here, you can see here you can associate more than one application here. So you can see on the dialog box you have 1 here, and then you have 2 here. So you can associate multiple instances of the app to each instance of the MySQL database. So
cool.
Okay. So the next I want to show is a live application. So this is actually a Google App Engine application that I wrote. At Google, we have a problem here. We actually allow people to ride bike between buildings, and a lot of times the bike will be broken, but there's no good way to report the broken bike. So what people do is they just take out the seat and then they just put it in the basket. But I have this idea of writing an app that allows people to take a picture. And when they take a picture, the broken bike will go to the App Engine, and then the App Engine will store in the MySQL database. So here I have some sample data that you can see on the screen. So each marker represents a broken bike. So if you click on the marker here, then it will pull out the picture of the broken bike, and then you will see who reports it and the data report, the day of the incident. So you can.
Did you build this in Java or Python?
I built this in Java, so I'm going to show you
the
code
cool.
here. So the code is very straightforward here. So I have a JSP page called gbyte.jsp. So in the gbyte.jsp here, so this is the page that actually get the list of broken bytes and then display on the map. So I wrap the database into an object called gbytedb, and here it's really important I create a connection first. So this, I use the standard Java driver manager to get a connection to the database, and then I call my database object and then get the list of broken bytes. So
see, all that's just vanilla JSP.
Yes,
Java and
vanilla
JavaScript.
JSP, yeah.
So that could be running on anything.
Right. So if you look at the method to get the broken byte is really just straightforward. It's just a select statement right here, and then prepare the statement and execute against the database. So
anyone that's built JSPs or JDBC, that should be second nature to be able to use it.
It'd be trivial to port stuff over to the platform.
Yeah.
So there's something that I want to point out right here is the connection. So it is recommended that you create a connection at the beginning of the servlet, and then after you're done with it, you close the connection. And there's a reason for it. Because the way the MySQL database that is running on the cloud is very, very different than the MySQL that you run on a local instance. So when you set up a local box, you install your local MySQL instance, that instance will always run as long as your box is up and running. But in the case of MySQL running on the cloud, if your instance is idle, we will conserve it and we'll take it down and put it to sleep. So say if you try to hold on to a connection for too long, your instance of the MySQL running on the cloud may not be up anymore. So if you try to use the connection again, you will get a invalid connection in that case.
It's worth pointing out that this idea of not using connection pooling, a pattern that we've all been familiar with. If you were using connection pooling, you'd still have to test every connection. Now on MySQL, it takes as long to test a connection as it does to create one. So this method is just as fast as connection pooling. You're not losing any performance.
I think it's even a little bit faster. I remember talking to one of the it's like tiny bit. Like it's just so much faster just to open a brand new connection. That it's not even.
It then makes the application so much easier to manage. You can take it up and take it down.
Well, and your data center may go away somewhere, and your application
Those hunters
seamlessly work somewhere else, right?
Yeah.
That is the benefit of cloud. So you just don't know.
Yeah.
Very cool.
Okay, so
now did you have to put I can't see the screen from here, but did you have to put you didn't have to put a username and password in there, right?
No, I don't.
Connect, because that's part of when you initially created that link.
Yeah.
Right.
Because it makes it really easy to use.
Yeah.
It's a very robust security model, actually directly authorizing that application.
And what about users? Can you can give it to applications, right? In this case.
Oh, sure, yeah.
But we can also give it to users, right? If you want to be able to use maybe some of the command line tools or.
Yeah. On that GByte thing, it's worth pointing out that we're using Cloud SQL widely internally. We're using it all over the place within Google. The org chart is in Cloud SQL.
Yeah.
So Larry Page is CEO because of Cloud SQL.
Yeah.
I like
we like to use our own technologies, dogfood, and we do have a need for relational databases inside of Google as well. So for sure.
Okay, so the other thing I'd like to show is how easy it is to use a command prompt to log onto the instance of your MySQL.
There we go. Cool.
So here, Google actually provided a command shell utility that you can use. So to use it, all you have to do is to download that the package and then specify the name of your database instance. So on the screen, I have that already ready to go. So
your instance is waking up, maybe.
Okay, so once the command comes back, it's a very familiar SQL greater than sign here. So you can say show database. Okay, so these are the very, very familiar to you. It's just the standard SQL syntax that you can use. So.
And you can use this command tool for scripting as well, right?
Yeah.
If you want to write scripts to export things.
Right.
I remember my old SQL days, I used to do a lot of scripting and have to get things in and out.
You'll end up doing a lot less of that.
Yeah.
Because there are tools for, say, importing and exporting the data neatly into the cloud, into cloud storage.
Okay, so just to show you how I can import the database very easily, I have here a database schema, a sample database schemas. So in this sample database schema, I have about close to 80 tables, and you can see the schema here. So one thing I want to point out that here, if you look carefully here, when I do a MySQL dump on the original database schema that I have, the engine is all set to my ISAM. So I took the care, I actually changed all of my ISAM table into InnoDB table, and there is a reason for it. The reason is that my ISAM performance is very, very slow compared to InnoDB on the Cloud SQL. So you have to make sure that you use InnoDB.
And you don't have the same referential integrity constraints.
Correct.
For a whole bunch of reasons.
Yeah.
Stick with InnoDB.
So in order to say import this database schema into the the Cloud SQL, all I have to do is to do the same thing. So so I run my Cloud SQL command prompt, specify my instance, and then just redirect my SQL schema in there, and then it will be chunking. Because there's close to 80 tables, it's going to take about a few minutes.
Yeah.
So.
Nice.
Very cool. So wait, I'm sorry, I can't see from here, but what exactly are you importing? Is this
it's a database schema that I exported from another.
Okay, from another database. So you're just importing it into.
Yeah.
Now, can you take, let's say I'm a developer and I have MySQL on my desktop.
Yeah.
Can I import my MySQL, backup into Cloud SQL?
Yeah, you can take a dump from your local machine and import it, upload it into cloud storage, and
actually, it's worth pointing out cloud storage and how. I don't know if we talked about that, but it may or may not be apparent. But one of the nice things is this is also linked into cloud storage. And you can use cloud storage to take snapshot backups of your data and dump them in there, so you can pull them later.
You can take an import and export anytime you like. We've also got managed backups, which we take, and you take them nightly included as part of the price. Seven backups are stored, which are done in a scheduled manner, and you can restore from any of those, as well as getting your data in and out.
Yeah, it's a good mechanism for moving data back and forth.
Yeah.
So
it tends to be a little bit quicker than using than doing it from the command line.
Oh yeah, because of the network traffic that you have to go through.
Yeah.
So. But that's a nice use of how you just use your standard scripting, MySQL scripting on the.
So if you have scripts that you've already built to get certain stats out or data out or import-export stuff, you can sort of reuse that.
So the import process just finished.
Okay, cool.
So we can
check it out.
Yeah, we can check it out.
We don't have to. I believe you.
I believe him.
It just works. Cool. The other thing that's actually kind of worth pointing out, there's a tutorial for this as well, but you can also, if you have Java tools that use JDBC, so for instance, SQL Squirrel, what is it called?
Yeah, there's a bunch of them, SQL Squirrel.
Anything that uses a JDBC driver, you can basically, if you have a tool that you use to manage your data, and it has a standard, and it has the ability to use a standard JDBC driver, we can basically plug that in.
Crystal reports, all the standard admin and reports.
So that's another nice benefit, I think, that maybe doesn't come across a lot.
Okay.
Cool. Did you have anything else, Wally, you wanted to talk about?
Oh, I think that's all I have.
Okay, great. So this is awesome. I mean, let's go ahead and take a look at some of the questions people have. I have our Google moderator here. It looks like we have 9 questions from the audience. So we'll go ahead and go through these. So I'll just sort of ask the question out loud, and you guys can jump at it. So the first question is, considering a scenario that one has a website serving an application using Java and MySQL, and it's not being migrated, how will MySQL go in the App Engine database? So I think this is just an export.
Yes, I think there might be a slight confusion when they're talking about the App Engine database. Okay. Do they mean data store?
Data store, okay.
Yeah, we've got data store is your NoSQL database. Cloud SQL is a SQL database, hence the name.
Yeah.
So the MySQL wouldn't go into the data store.
It would go into the
Cloud SQL.
Yeah. So it would go from MySQL, your server, into the Cloud SQL, which is equivalent. So you could reuse.
And I hope the demo that I just did will answer his question as well.
Yes.
So it's just to show you how easy it is to import your data from existing.
If you go to the Cloud SQL homepage, click under Tools and Resources. There's a there's a page on how to import and export your database.
Yeah.
It's very straightforward.
Very cool. Okay, great. The next question is from Hector, and it's triggered and stored procedures. Is it supported? If so, what kind of interaction can we implement within the App Engine code? I have some thoughts on this, but maybe you guys have some more.
Hector's in Martinique. If he invites us out
Yeah.
there, if he invites us out there, and we'll demonstrate it in person.
Exactly.
Yeah. So triggers and stored procedures, yes, they're supported. We don't support user-defined functions. There's a couple of things like that which purely for cloud security aren't implemented, but triggers and stored procedures are. What kind of interaction can we implement within App Engine code? I'm just tempted to say all the standard stuff you do from an application in Java and Python.
Yeah, I mean it should work.
So cascade deletes, auto updates.
Yeah, I mean anything you open a connection to the database and execute a query, right?
Yeah.
Same thing should work here. So that's cool. A slightly unrelated question from Levy, which is, would you please consider adding a pricing calculator for GAE? And I think this is a really great idea. I think we've been wanting to do this for a while. So I'll go back and talk to the team about it. It probably would be good to have a pricing calculator for Cloud SQL potentially, though it seems pretty straightforward to me.
Yes, it's a slightly different pricing model because we listen to how people wanting to use it.
Yeah.
The preference within App Engine, everything managed. You want your quotas.
Yeah.
Within Cloud SQL, you don't particularly want your instance to be turned off halfway through the day.
That's true.
So it's a slightly different pricing model.
That's a good point.
How people were using it differently.
That's true. Okay, cool. We have a question from Mohammed, which is, I want to use Django on App Engine with Cloud SQL. What's the maximum number of concurrent requests that can be serviced? Let's start there. I have some thoughts on this, but do you guys have any thoughts?
Firstly, yes, there's an article on using Django on App Engine.
Yeah, the Getting Started Glide.
Yes. And Django is a really nice framework for Python, but whenever you start using a framework, you get a trade-off between performance and productivity and ease of use. And there is that trade-off with Django. It adds extra overhead. To the maximum concurrent requests that can be responsively served, how long is a piece of string? It depends so much on the particular application. I'd really suggest trying it out with your particular application.
Yeah, I would say benchmark it for sure and just see what ceiling you hit. And there's a bunch of strategies to sort of get around that. You can add more instances. You're not just tied to a single instance, right? You can actually like shard instances. I've seen people do this before. Wally might have some other thoughts. But
Isn't there maximum connections that we can have for MySQL, the Cloud SQL?
Yes, around 100.
Yeah.
But I think that's more a question of performance rather than just the concurrent connections. I think.
Yeah, I would say to try to benchmark. I mean, I think that's probably the best way. And then if you do run into issues, there's a couple different ways you can interact. We have a discussion group, but we also use Stack Overflow. So there's a Cloud SQL tag on Stack Overflow and an App Engine tag. So if you definitely have questions or you're running into problems, post to the community or back to the discussion group. And
I think there's a wider point in general about the different philosophies between NoSQL and SQL. In some ways, people have been a little sport with data store because it is so scalable. You can just throw queries at it, and you just won't see any difference. Cloud SQL, because it is relational, because it has robust ACID transactions, it's more of a fixed pipe.
Yeah.
In order to maintain those acidic transactions, there are more limits on what it can do. Therefore, it's always advisable on doing a load testing with any new application, especially if you're expecting a big peak in traffic. We wouldn't want you to get slash dotted and hurt. It also reflects the type of applications that each one is more suitable for. If you've got an application where you want to do some kind of logging, you're just dumping data, very, very fast reads to a data store. Data store will be a better fit. If you've got much more structured data that you want to do many more generalized queries on, but don't want to worry about maintaining your own indexes, Cloud SQL would be more suitable. So think carefully about what's going to be the most suitable data store, the most suitable way of storing your data. As Ian mentioned, there's that great talk from Google I/O. If you go to the Google I/O videos, look for Battle of the Backends.
Yeah.
They go through a few key use cases there.
Yep. Very. The one other interesting part of this question, which is asking about if the app was database read-write intensive or read intensive.
Yes.
But I think the crux of the question is sort of towards the end is what happens if traffic exceeds that limit? Do we throw exceptions, or how do we throttle that back?
It will degrade gracefully up to the point at which your App Engine responses are timing out.
Got it. Okay, cool. All right, we have another question here from Kastub. I apologize if I didn't say your name right. The question is, considering a scenario where there's a website serving an application using Java MySQL, and it now needs to be migrated to App Engine. Oh, this seems a duplicate question, or
question
it moved. The question moved. The question moved. Okay, this was real time, so there we go. That's humor for the day. How do I implement parallel authorization for my App Engine app with Google ID along with my website ID? How does that concept work? I think the question here is about using the Google user service to the user API to basically authorize a Gmail user with or a Google Apps domain with the application. But I don't think that concept follows down into the database unless you want to explicitly authorize.
As with the rest of the console, you can authorize
individual users
to be to read or write.
Yeah, I don't think it would make sense to say like all 100 people in the domain would get access. You have to manually authorize it. I think if I understand the question correctly. But there's good documentation on the users API for both Python and Java, and then you can also look at the section on authorization for Cloud SQL. It does talk about per app as well as individual users. Is it possible to integrate an app running on AWS to use Cloud SQL?
Yes.
Okay.
Yeah, we've got JDBC.
JDBC can do.
Yeah, and that'll work. Always bear in mind that if you're running applications on a different network or remotely from the database, then your latency, you'll take a hit there. Mm-hmm. But yes, certainly possible.
Okay, cool. So you can use Cloud SQL from other cloud services.
Yeah, from anywhere else.
Okay, great. Okay, so let's see. What do you call? I'm trying to intuiting this question here, which is sort of. What do you call a product developed on App Engine as a whole in terms of cloud infrastructure as a service, platform as a service, or software as a service? I think this is generic talking about App Engine. And I think App Engine is platform as a service, right? Yeah. So there's no infrastructure you run or manage, you write your code. And Cloud SQL fits into that bucket as well.
Yes, it takes away that layer of headache.
Yeah, you're not managing a Cloud SQL server or instance, you're not backing it up, you're not starting, stopping maintenance. So these are all part of in the platform as a service suite where it's really focused on developer productivity.
Isn't there a term called DB as a service?
There is also database as a service. I've heard that as well. I mean, exactly. But I think they're all in sort of the platformish layer. Okay, great. Totally unrelated question about 4 Nexus devices showing up in my Gmail account. I'm not sure what this is about, so we're just going to skip over. He's asking for an option to troubleshoot. I would say take a look at the Android developers page. I'm sure there's some support forums there somewhere. And then this last one doesn't make just a website link. So I think we have got all of the questions. I'm going to double check that nothing popped up here.
Trigger store procedures, good to go.
Pricing calculator,
good suggestion.
Yeah. Django,
yes, it's a very nice framework, but you might take a performance hit. But should try it out for yourself.
Oh, okay, here's a new one. How will multiple requests be handled on the same database and table in Cloud SQL?
It's the same as standard MySQL, so that they're mutually exclusive write locks.
Okay, cool. And I think we got all of the questions here. This is great. I'm really happy. People can go to learn more at developers.google.com/cloudsql.
Yeah.
There's an active developer forum as well as the App Engine forum you can post as well. the last question I have for you, Joe, and I don't know what you have cooking. Do you have any glimpse of the future of Cloud SQL? Any new stuff coming out? I mean, if not, that's cool. But I always like to ask for our audience.
The main thing our guys have been working on for the last few months has been performance, and you should have seen some good improvements, including things like making backups a lot faster. We've got some interesting stuff in the works just around the corner. I was really hoping to be able to talk more about them. Not yet.
Not yet. Okay.
Not yet.
All right. Well, cool. I mean, we'll definitely, we love Hangouts. It's a great vehicle to communicate with people, and so we'll have you on again as a special guest host.
But especially when we go to Martinique. I think take the road show to Martinique.
Yes. Okay. Awesome. I agree with you. We need to do these things remotely, and we'll have to bring our illustrious studio here.
Of the technology.
Yes. Exactly. So I guess with that, we'll go ahead and wrap up and close this GDL session. I want to thank everyone and our guests here, Wally and Joe. Thank you for making some time, and stay tuned. Keep an eye out. We'll have some more App Engine Hangouts coming on in the next couple of weeks. So thanks everyone, and I'm going to sign off.
Thanks.
So long.